the journey of Wi-Fi is just incredible. I mean, think about it. It went from a technology that could barely load a single web page to something that now promises near-wired performance for our most demanding apps. So, let's dive in and see exactly how we got from there to here.
Okay, before we get started, just so you know where all this great info is coming from, this is part 9 of our 20-part series. It's all based on Chapter 9 of a super detailed technical report on Wi-Fi and Bluetooth standards from the experts over at RFI Detectives, who are part of Virtualization Options LLC.
Which, of course, brings us to the big question. We've seen a performance jump of over 20,000 times. How on earth did that happen? Well, spoiler alert, it wasn't just one big invention. It was actually a whole series of brilliant solutions to some very different problems.
We're going to break this whole evolution down into 5 key stages. We'll start with the early days, then look at the major speed boosts, tackle the problem of congestion, and finally, we'll land on the brand new Wi-Fi 7 and talk about what it all means for you.
All right, take a look at this. This chart from the RFI Detectives report, this is basically our roadmap for this whole journey. It lays out every major Wi-Fi standard from the very beginning right up to today. We'll be pointing out the key milestones from this table as we go.
So let's rewind the clock and start at the very beginning, with the standards that first cut the cord and made wireless networking a real thing for everybody.
Okay, so the real breakthrough, the one that got the ball rolling for everyone, was back in 1999 with 802.11b. This is our starting point. It gave us a top speed of 11 megabits per second. Now that doesn't sound like much today, but back then, it was reliable enough to get huge adoption and really, truly kickstart the wireless revolution.
So for the next 10 years or so, speeds got a little better, incrementally. But the next massive leap happened when the problem itself changed. It wasn't just about connecting anymore. It was about connecting fast. Then, in 2009, 802.11n, what we now call Wi-Fi 4, showed up. And man, did it ever change the game. This was the moment Wi-Fi became a serious contender for high-bandwidth stuff.
So what was the secret sauce? A technology called MIMO. The easiest way to think about it is this. Instead of a single-lane road for your data, MIMO built a multi-lane highway by using multiple antennas to send and receive several data streams all at once. For you, the folks managing networks, this was huge. Suddenly, things like antenna diversity and placement became critical for getting the best performance. And the result of all that? A massive jump from 54 megabits with the last standard all the way to a theoretical maximum of 600 megabits per second. I mean, that's not just an improvement, that's a whole new world. This leap is what made streaming HD video over Wi-Fi totally normal. But of course, with all that speed came a brand new headache. What happens when you have dozens or even hundreds of devices all trying to use that speed in the same space? The next era of Wi-Fi wasn't about building a faster car, it was all about better traffic management. And this is where we see a really fundamental shift in the whole philosophy behind Wi-Fi. Wi-Fi 5 was all about getting the absolute highest speed to just one device. But Wi-Fi 6, our 802.11ax, changed the goal completely to achieving peak efficiency for lots of devices all at the same time. And the hero of this chapter is a tech called OFDMA. Look, if MIMO created more lanes on the highway, OFDMA is like a super efficient delivery truck that can carry packages for a bunch of different houses on a single trip, instead of making a separate trip for each one. It just massively improves how well the network runs in crowded places like offices, airports, and stadiums. And yeah, of course, the top-line speed got another huge boost, all the way to 9.6 gigabits per second. But honestly, the real story of Wi-Fi 6 wasn't just about that big number. It was that everyone on the network got a much better, smoother, and more consistent experience, even when things got crazy busy. Okay, so that brings us right up to the present day. We've got basic connectivity, we've got raw speed, and we've got efficiency in a crowd. So, what's left to solve? Well, the next frontier is all about delivering extreme throughput with ultra-low predictable latency. So let's talk about 802.11b, or Wi-Fi 7. And let me be super clear here. That's 802.11be. We are not talking about the old 802.11b from way back in 1999. This is a whole different animal. The RFI Detectives report just nails it. The goal for Wi-Fi 7 was crystal clear right from the start. Deliver performance so good and so reliable that it can handle the most demanding real-time applications out there, things like industrial automation and high-fidelity virtual reality. And the numbers are just staggering. I mean, get ready for this.
The theoretical maximum throughput of Wi-Fi 7 is 46 gigabits per second. That is nearly 5 times faster than Wi-Fi 6. It's practically knocking on the door of wired multi-gigabit Ethernet speeds.
So how in the world does it pull that off? Well, it's really 3 key technologies working in concert. First, you've got these ultra-wide 320 megahertz channels, which are like even bigger data highways. Second is something called 4096 QAM modulation, which is a fancy way of saying it packs way more data into every signal. And finally, the crown jewel, multi-link operation, or MLO. This is the real superstar, letting a single device connect across multiple radio bands at the exact same time, which boosts both speed and reliability like crazy.
Okay, so we've thrown a lot of acronyms and speeds at you, but what does all this actually mean in the real world? How does this evolution impact the networks that you're building and managing every single day?
This right here really brings it all home. MIMO and Wi-Fi 4, that's what lets us stream Netflix in HD without a problem. OFDMA and Wi-Fi 6, that's why your connection is actually stable in a packed conference hall. And the new tech in Wi-Fi 7, like MLO, that is what's finally going to unlock the most demanding, latency-sensitive stuff, like real-time industrial robotics and truly immersive augmented reality for the enterprise.
So if there is one thing you take away from all of this, let it be this. The story of Wi-Fi's evolution isn't just a simple race for more speed. It's a story of elegant engineering, with each new generation stepping up to solve the biggest wireless challenge of its time.
And that leaves us with a really fascinating question, doesn't it? With Wi-Fi 7 delivering performance that can actually rival a physical cable, you have to wonder, what's next? What's the next big problem that Wi-Fi 8 is going to have to solve?